So to find the domain of the composition, we have to think a little bit about what a composition does. If I said I wanted f of g of x, in order to get my final answer, whatever I plug in for x has to exist, right? If I plug in something in, I get no solution off the bat. Is it going to work from there? No. So we have to do the domain of the inside function. And so two-step process, it has to work at the very beginning, and then I have to get an answer when I plug that into the outside function. So it's the domain of the final expression. Okay, we have to put both of these together to get the final domain in our composition. So we can't only look at the final answer. We would get the right answer sometimes, but not all the time. So we have to look at both pieces. For instance, if I gave you this one, I think the easiest option, if you're looking at Math Excel, it's going to tell you a little different method, but I think the easiest option is to go ahead and do the composition first. So we know f of x is x squared plus 3x minus 1. On our compositions, we start on the inside. And then we take that and we plug it into g. So g is times 2 times whatever we plug in plus 3. And I'm putting in my x squared plus 3x minus 1. All right. So if I distribute that, 2x squared 3x, plus 6x. Minus 2 and our plus 3. 2x squared plus 6x plus 1. That's my final answer. Now obviously if I ask for domain, it has to work here. Do I have a fraction? Do I have a square root? So what's my domain? Negative infinity to infinity, right? We can plug in any number we want for x. But in order to get there, whatever I put in to start with had to give me an answer. So we have to look at this inside function. Okay, if I have x squared plus 3x minus 1, do I have any fractions? Any radicals? So what could x be on that one? Okay, we put both of those together to get my overall domain, so this one's fairly uninteresting. It can be anything. I can plug any number in for x, because no matter what I plug in for x, I get an answer for the first one, and I can take that answer and plug it into the second one. So we'll do the composition. We're going to look at the final answer and the original inside function. Let's look at this one. If I want the domain of f composed with g, what I'm going to do is first do f composed with g. What is g of x?
Where are you going? Get here.
All right, so let's plug that into f. So f is 1 over the thing we're putting in plus 2. And so the thing I'm putting in is that 4 over x minus 1. All right. From here, is that good notation to leave a fraction in a fraction? No. The easiest way to get rid of it is to just multiply by that denominator. So I'm going to take top and bottom times x minus 1, that denominator. So 1 times x minus 1 is x minus 1. What happens if I take 4 over x minus 1 times x minus 1? Cancels and just gives me a 4. And then we would have to do the 2 times x minus 1. Okay, so if we distribute, combine like terms, so we get x minus 1 over 2x plus 2. All right, so that is my composition. We were doing compositions yesterday. That was an uglier one because we had the fraction and a fraction. Are there any questions on it? For my domain, I know on my final answer, I have a fraction. If you have a fraction, what's my domain rule? The bottom can't be 0. So 2x can't be negative 2. So x can't be negative 1. Okay. So I know in my domain x can't be negative 1. Would you have gotten that by looking at these original ones? No. This one tells me x can't be negative 2. This one tells me x can't be 1. So I'm not going to get my domain from the original two. We have to look at the composition. But this doesn't give me the whole picture. All right, if I'm looking at this, could I plug a 1 into that final answer? Yeah. What if I just asked you to do f of g of 1? So if you plug a 1 into g, what happens? You get 0 on the bottom. Can we do that? No. So that's why these compositions, the domain is 2 parts. You have to look at the final answer, but we also have to look at the inside functions. So the very first thing I do, no matter what I pick for x, I have to plug it into 4 over x minus 1. It's a fraction, so I know x minus 1 can't be 0, so x can't be 1. My final domain, if it's just one value x can't equal, I expect the interval. If it's more than one, I will allow you to tell me. So x can't be a positive or negative 1. The interval itself, if you think about it on a number line, it's everything except negative 1 and 1. So the interval would be 3 pieces. It's negative infinity to negative 1, union negative 1 to 1, union 1 to infinity. So on a test, I would let you just tell me if it's more than one thing, what x can't equal. Math Excel today might ask for some intervals, so just make sure you can do that. All right. Questions there? So make sure you're looking at both parts. Let's try another one. I ask for the domain of this composition. What would I do first? Well, I'm not telling you. Somebody can tell me what my first step is. doing the composition. Even though I only asked for the domain, we have to do the composition to get it. So my f is 3 over x minus 1. I'm plugging that into g. So g is 2 over the thing I'm plugging in for x. How do you divide fractions? So 2 times x minus 1 over 3. So I get 2x minus 2 over 3. All right. 2 places I have to look for my domain. The first one is right here. When I look at that, it's a fraction. I know in a fraction the bottom can't be 0. Can 3 equal 0? No, so this one's telling me it could be anything. Where else do I have to look? Yeah, the very first expression, the original inside. So if I look there, x minus 1 can't be 0, so x can't be 1. So if I put these two together, what's the only thing x can't equal? 1. So my answer is negative infinity to 1, union 1 to infinity. I want you guys to try the next one. Do f composed with g first, so f of g of x. So g is x squared plus 4. If I put that into f, f is whatever we plug in, squared. How do I square that? Okay, so that gives me x to the 4th plus 4x squared and plus 4x squared and plus 8x squared plus 16. So a couple of you just tried to distribute that square, and I think a couple of you might have done g composed with f instead of f composed with g. All right, so domain. We look 2 places. The final answer, and the original inside. What do you notice about the domain of both of those? No fractions or radicals on either, so my overall domain is everything. Let's try another. All right, so if I want g composed with f, so f is the square root of x plus 2. If I put that into g, 2 over the square root of x plus 2. All right, are you supposed to leave a radical on the bottom? No, do you remember how to fix it? So that gives us 2 radical x plus 2 over x plus 2. All right, domain, 2 places. If I look here, what do I know? That's here. Yeah. So if it's a radical, the thing under the radical has to be greater than or equal to 0. So x has to be greater than or equal to negative 2. When I look over here in a fraction, I know the bottom can't be 0, so x can't be negative 2. So it has to be greater than or equal to negative 2, but not negative 2. What would my domain be? Careful, this one already said greater than or equal, so that's only the positive. So I already took out the negative thing too. And then this one took out the 2, so it's just negative 2 to infinity, but you have to have a parenthesis because it's not equal to 0. All right, Do we need to do more of these? So look, do your composition, then look at the first inside function and your final answer. So Math Excel is due tomorrow. You have a lot of time to finish that right now.